Yes, today's Wall of Wind tour will be narrated and conducted by our laboratory manager, Walter Conklin, with one of our PhD students, Manny Matos, as the cameraman for him. So with that, I will turn it over to Manny to share his screen.
Good. Good afternoon. Mal, how much time do we have? I know you guys go on break.
Yeah, I think we are late anyway, so you can
okay, we'll try to make it. We'll try to make it.
Yeah, maybe try to keep it about 10 minutes or so, Walter, and then we can.
All right, we'll walk fast. So good afternoon. My name is Walter Conklin. I wear two hats here. I'm the laboratory manager and the health and safety manager, and I'll be speaking about both.
Screensaver backward. Manny, your screensaver is on.
The Manny, your screensaver is on.
Or your visual background.
Yeah.
There you go.
We're good? All right.
Yep.
So as I said, I'm wearing two hats. So I'm going to be talking about the lab as well as safety as we go forward. And Manny Matus is going to be following us during the tour. And if you have any questions, chime in. I can hear you through the mic.
If I can,
so we're gonna
Walter, I'm sorry. If I can just advise everyone to do the speaker view so we can you can see the entire screen. Yeah. Thank you.
All right. So we're going to enter the Wall of Wind. When we go in, we're going to show you the control room, and we're going to show you some of the smaller scale projects that we're working on, and also some of the safety procedures. COVID related, we have a lot of signage around the facility dictating about social distancing and wearing protective equipment, and we'll go into that as well as we go inside the facility. We're going to give you a quick view of our control room to give you an idea of where we take the data and video, and then we'll go into the Wall of Wind. So right now we're going through a few upgrades. So we have a little bit of equipment around. We're about to upgrade all the computers in our control room, so you'll see some computers out of place. But this is our control room. And we do our data acquisition. So all our data acquisition is coming from our turntable area. So under the turntable, we have Ethernet connections, and all of our data acquisition goes through Ethernet and comes to our data acquisition computers. On this section, we have our high definition cameras that we record for clients, as well as we have a telepresence. So we have surveillance cameras all over the facility that we give access to clients to view testing as it's happening real time. And when you log in, you're able to see this view as well, which tells you what tests we're doing, what angle we're at, the speed. And then this section is our control, where we control the Wall of Wind from here. So a minimum, we have 2 people in here to run testing at any time. And again, you're able to log in, and we'll give you access to cameras in order to view the test. In the future, we're working on giving you access to the data feed as well, so you can see the live data, not the files itself, but the live data, and that'll be in the future. And now we'll go into the Wall of Wind. And just to show you a few of the smaller scale testing, this is testing with the Department of Environmental Management through the state of Florida, small scale for irregular shaped buildings. And you can see all the pressure taps we have on there, as well as all the connections in the back. And then we're working on an NSF with Stanford and Dr. Gorley. This is only a section of the building, but this will also be pressure tapped and will be placed on the turntable along with a representation of the surrounding buildings as well. So we're going to go into the Wall of Wind. Some of the safety we had, even prior to COVID, we have all the helmets and everything. Right now we have plenty of masks. So everybody that needs a mask, we can grab a mask. We have our hand sanitation, and we have wipes to wipe everything down. And we'll continue inside. We'll show you the actual fans first, and then we'll walk into the Wall of Wind. One of the things we're going to add, it should be in the next week or so, we're going to have a trailer, about a 36-foot trailer that we're going to place here, also because COVID related. So if we have any outside colleagues that want to come in and view the test live, and you're allowed to travel, we're going to have a separate space here for social distancing. And we're also using it for students as well to keep social distancing as well. So this is the intake side of the 12 fans. The doors aren't all the way open, but it's basically showing you the fans. These are 700 horsepower electric fans. The ducting wise, they're 6-foot diameter fans with the cowling and everything. They're about 8 feet. These work off medium voltage, which is 4160, 4,000 volts. And they both work in tandem using VFDs, variable frequency drives, to change the speed of the fans. And they all work in tandem. We're not doing any gust or anything. That's all done through the flow management box, which we'll show you on the other side. So that's basically what to show you on this side. These doors open up to 50 feet. Right now they're not open all the way. And then we're gonna go ahead and show you the intake side in one of the experiments we're running right now. And just to give you an idea, we also have, working with FIU, we have signage for social distancing and having masks on, as well as we have hands in both buildings for anybody that needs to do hand sanitizing. I'm gonna go through the outside and show. So currently we have some PhD students working on a project, our downburst project, which we should be testing in a few months. So this is the exhaust side of the wall of wind. Right now we have a testing going on with IUCRC, which is a industrial partnership program. And this is, we're testing double-walled facade, glass facade. And to give you an idea of this section over here, I guess Manny could turn. This is our debris field. We have a 15-foot concrete wall in the back. And then we installed, over the summer, we installed this netting to stop any small debris that gets created from the large debris. Typically, we'll have little small pieces that get away. So we decided, safety-wise, to put the netting to help that. This is also going to act as a barrier for laser light. We have another blackout netting that goes up. It's not up right now. We have blackout netting that goes up. So pedestrian level, there's no issues with any reflection of any laser light. And that's when the PIV system comes online sometime this year. So this is the turntable. Allows us to put many different sizes. This is considered a full-scale 1-to-1. We're not testing the full building. We're testing the portion of it. So we're testing the windward side of the building. There's a certain give and take when you get to 1-to-1, depending on size. So we get blockage effects. So depending on what you're doing, what test you're doing, you can have different size samples or I can lost a word there. I'll show you. This is our scanning valve system, part of it, which we do the pressure measurements with. Typically, this is underneath the turntable. We're about to do water testing with this test specimen. We did all the dynamic and pressure testing first. And then once we finish that, we remove the instrumentation, and then we're gonna do water penetration testing next. So that's another unique feature of the wall of wind, that we're able to do wind testing as well as wind-driven rain testing. This is our flow management box. Basically, we're trying to mimic as close as possible hurricane winds. or natural wind. Doesn't necessarily have to be hurricane wind. So as the wind, the fans generate the wind, it goes through a contraction, which speeds up the air. It comes into the box, which first you have the spires. The spires are adjustable, and depending on if we're doing open terrain or suburban, we could open them or close them. Right behind those spires are nozzles for the water injection system. And then as it continues, we have this roughness elements on the ground. And again, what we're trying to do is create high turbulence, low speed on the near surface. And as you go up, you get the higher speed, lower turbulence. And that's what we're able to adjust depending on what type of exposure we want. I know for that project, we're going to be putting our actuators and having our specimen installed on the turntable. And just to give you an idea, we have access underneath. You have about 9 feet of access underneath the turntable. And we're gonna, the bottom part of the experiment with the actuators and so forth are gonna be underneath the turntable. And in order to get it stiff, we're gonna be connecting directly to the turntable, as well as we have an option to connect directly down to the concrete to give it stiffness if needed. This is it's new to us. We're working on creating that capability here at the Wall of Wind together with Lehigh. I don't know if I have any more to show. And let me know if I'm missing anything or if you want me to show anything else.
I think you did a great job, Walter. I can give few remarks about this model here. This is a double skim facade. Can you hear me?
Yes,
Yeah.
I hear you.
Okay. This is a double skim facade structure. Like, this is full scale model for this type of curtain walls. And we're trying to assess the interaction between wind-induced vibration of the facade system and the resulting wind-driven rain performance. So how many or how big is the amount of water intrusion that goes into the model, and how this is connected basically with the vibration of the system. So we're doing like dry tests, measure accelerations, strain gauges on the glass and also the mullions, the structural system supporting the glazing. And then we remove these type of instrumentations, and then we do wind-driven rain, where we measure the water intrusion, basically using some absorbent materials. If you have any questions about this one as well, let me know. Thank you. Thanks, Manny. Thank you, Walter.
Thanks. All right,
Thank you, Walter. Thank you, Manny.